All right, so chapter 6-7 is called similar figures. And basically it's more ratios. So you've got two shapes that are the same shape, but one's bigger than the other. Okay. And so proportionally, we're going to set these up as proportions to find the missing side length using proportions. And by this point, we should be very good at solving the proportions once we have them set up. So really the only tricky part is setting these up. And when I say tricky, it's not really that tricky, but that's the only tricky part. That is, if you can do that, you can solve these easy. All right. So the first thing I want to do is I'm going to use my highlighter here. And I'm going to highlight matching sides. So what do I mean by matching sides? Well, my two figures, and they usually will draw like angles, like lines and angles to tell you which angles match up. Now, this first example, they're really nice because they're both sitting in the same, neither one of them are twisted or tilted. They're sitting right on top of each other, pointing in the right direction. So it's obvious that this angle matches this angle and this angle matches this angle. Well, what that means is that as far as similar sides, this side and this side are considered similar. Okay. Then if we go to the other side, we've got matching sides elsewhere where we have numbers. And so we have a number here. And so the matching side to that is right here. Now, all that tells us is which sides correlate with each other. Okay, so that's kind of the first step, is just deciding which sides match each other. Now, the part where you have to actually set up the ratio. So if you take the smaller triangle, the ABC triangle, okay, and I'll do that one in blue. I'm going to use the 4 and the 12 from that one triangle equals one fraction. And I'm going to put it as a fraction. And I don't care which one you put on top. Okay, 4 over 12 or 12 over 4, it doesn't matter. But one triangle goes together as one fraction. Now we're going to go to our second triangle, and in the second triangle, we have a 6 and an X. This is the part that matters. However you set up triangle number 1, you got to have matching sides on top and bottom. So if you look at triangle number 1 and triangle number 2, the purple highlighted side is the matching side. So that means that in my second equation or my second fraction, I need to have on top the same side that was with 4. Look at the other triangle and what side is the same side, and that would be 6, right? So the 6 goes on top. And then looking at the bottom of the fraction, we got from the smaller triangle, we got a 12. From the matching side, which is the same side of the shape, we have an X because that's unknown. So that's what we're solving for. So the first ratio doesn't matter which one you put on top and bottom. The second one has to match the first one as far as which sides, because what should happen, and if it did here, what should happen is that when I highlighted my purple side and my purple side, 4 and 6 should both be on top of my ratios, and they are. You look at my other, oops, let me change white to green. You look at my other line, and this was my 12 and my X, right? They should be on the bottom, 12 and X. So your matching sides should be in matching parts of the fraction. If you can get that straight, solving these are a breeze, because then you just simply cross multiply, and we know how to do that. 4 times X is 4X. 12 times 6 is 72. Divide by 4 and divide by 4, and we get X equals 18. And then how would we label this particular one? Yeah, M. You always want to look to your shapes to know how to label them. So my answer for the missing side of the triangle is 18 meters. And what that means is proportionally, okay, 4 over 12 is proportional to 6 over 18. And if we test it, if we're saying that 4 over 12 is proportional to 6 over 18, well, how do we test to see if two fractions are proportional? Can we reduce that one to 1/3? Can we reduce the other one to 1/3? You don't have to do that part. I'm just showing you what we're doing by finding X, is we're finding the proportional length to make sure that our two fractions are proportional, okay? All right, so I'm gonna do the same thing on this one. Before I get started, I'm gonna highlight my two sides. So not my two sides, my matching sides. So I'm going to come in and I'm going to say that GH on this triangle matches JK over here, right? Those two are matching. How did I decide that? Well, if you look at your little corner slash marks, in the corner of GH was 1 and 2. In the corner of JK is 1 and 2. That tells you they're not twisted. Then I'm going to look at my other one, which is HI, and I'm going to say that it matches KL. So what that tells me is my 2 purple lines should be in the top and my 2 green lines should be in the bottom when I'm done setting up my ratio. So now it's time to set up my actual ratio. So my first equation, I'm going to do the purple, or I'm sorry, I'm going to do the small triangle. Remember, 1 triangle, 1 fraction. So my first triangle, my smaller one, is the fraction 9 over 10, right? 1 triangle, 1 fraction. In my second triangle, my big triangle, which one am I going to put on top and which one am I going to put on bottom? What do you think?
The X.
X on top? X on top, because looking at my small 9 and my small 9 was purple highlighted. My big line that's purple highlighted is an X. They should both go across the top. Then looking at my other term for my big triangle is 30. And again, looking at your numbers, I had X and I had 30, 1 triangle, 1 fraction, but they're lined up right. Okay. And then I can cross multiply here and I get 10X equals cross multiply this way and I get 270. So when I divide by 10 on both sides, I get X equals 27. And how would I label this one?
27
inches, because those triangles are in inches. Make sense? There's 2 ways to do these. And I actually asked my husband last night which way was easier, because you can also set them up purple lines in a fraction and green lines in a fraction. But when I showed him both ways, he said doing same triangle, same fraction was easier. So that's what I'm sticking with. But so you guys don't even have to work number 5 if you don't want to. I'm just going to lay it out just really quickly here. I need to try to make this darker. Let's try that. All right. So if I have my matching side, right, it would be this one and this one line up. And then if I have my other matching side, it would be this one and this one. Okay. Those are the 2 sides that should line up. Now I have to kind of switch gears here, and it's 1 shape, 1 fraction, right? So 3 and 6 are the 2 numbers I'm going to use for my first fraction. So 3 over 6 is my first fraction. My second fraction is going to come from my 2 labels on my big rectangle, and I just have to worry about how I set them up. So which one am I going to put on top? Damien, what do you think? Say that again.
X on top.
Yeah, X on top, 32 on the bottom. And if I look at my setup, across the top should be my matching sides, and 3 and X are my matching sides. And then across the bottom, my matching sides were 6 and 32, and they go across the bottom. I'm not going to work it, but I just want to help set a few of them up. Now, on your homework, I'm not going to work number 4 because you don't have any like this on your homework. And I'm making sure you don't have one like this on your test. But look what happens to our shapes. They're rotated. So you just have to be careful, right? When you line up the bottom of this triangle, it lines up with the bottom of this triangle. And then when you line up the side of this triangle, it lines up with the side of this triangle. So if your shapes are twisted, you might kind of have to figure out what ones match up. Okay. Now the one I want to do like in your home, I want to do 7 and 8 because they are like, you have ones like this on your homework. All right. So this is just another way to show similar figures. You've got a tiny triangle up at the top, and then you've got the whole thing makes up a big triangle. So here's your tiny triangle right here, and I'll erase that. That's your tiny triangle. And then your big triangle is right here. Okay, that's your big triangle. And I'll erase that in a second. I'm just kind of showing you what I'm looking at. All right, so we want matching sides. So if I look at the bottom of this little triangle should line up to the bottom of the big triangle, right? And the little side right here, which is 8, it tells me that right here. My little side is 8 compared to my big side, which is 36. Okay, those are my sides and that match up. So now when it comes time to actually write a fraction, it's 1 triangle, 1 fraction. So Autumn, how would I set up my first fraction? 7 over what? 1. No, because that'd be setting up the bottom of 1 triangle and the bottom another. So 1 triangle, 1 fraction. So here is 1 triangle right here, right? That little bitty guy, what are its measurements? 7 over 8. Okay, there's 1 triangle. And then my other triangle is the really big one, which is this whole thing right here is my second triangle. So I'm going to set it up over itself. But what am I going to put a top and bottom? X on the top, 36. And what that means is my bottom of my little and my bottom of my big are both across the top. And the side of my little and the side of my big are both across the bottom. And then you would cross multiply and you would get 8x equals, somebody tell me what that is. What's 36 times 7? 252. And then I'm going to divide both sides by 8. And I get x equals what? 31.5. And how would I label it? And that would be your answer. And then I want to set up one like this. It's very similar. Okay. It's just 2 triangles with the points pointing at each other. But if this is the bottom of the big triangle, then this is the bottom of the little one, right? And if this is the side of the big triangle, then this is the side of the little. So the 2 purple lines are going to be on top with each other. The 2 green lines are going to be on the bottom with each other. So when we're setting up our little for our fractions, in low, what's my first fraction going to be? Remember, 1 triangle, 1 fraction. Okay, that's the first one. Good. And it doesn't matter which one you pick to go first. And then who hasn't? Sophia, what would be my second fraction? Good. 15 over 12. 1 fraction, 1 triangle, 1 fraction. And then because the 63 was the bottom, and then the 15 was the bottom, those 2 should be in the same side of the fraction. And then when we cross reduce, we get 15x equals what's 63 times 12? You guys are on it. And then when I divide by 15, I get 50.4. And how would I label it? Yards. Beautiful. Make sense? You don't have to use the highlighters if it doesn't help you. Totally do what you want to do. But if it helps you, use them. Okay. And then if you have one of mine, just bring it up at the end of class. All right. The back side of your homework is 6.7 and it's odds only. Okay. And you've got about 10 minutes. So you should be able to knock out a few of them anyway.
I thought it was like a lot harder. I might feel like it is, but
Yeah.
we started working on it first.
Yep. It looks hard because there's so many numbers going so many different directions, but I don't think it's too bad. All right. For those of you at home, if you have any questions, shoot me an email. I can always open up a Google meeting if you need to ask me more than something that can be covered in an email. And it's odds only. And let me know if you have any questions.